So on the forums, we saw a lot of confusion about Homeworks 2.5 and 2.6. Specifically, questions about what was going on with the linear algebra. So I want to talk about some of that today, and I want to do it by comparing the 2D case, and that's the case we talked about in lecture, with the 4D case, which is what you're asked about on the homework. Okay, so in the two-dimensional case, I want to first talk about this F matrix that Sebastian was calling the state transition matrix. The idea behind this matrix was that we wanted to take some old belief, some old state, which in the two-dimensional case was represented by x and x dot, where x dot is our velocity, x is our position. And from that we wanted to extract or predict some new state, which we called x prime and x dot prime. And the question was, what do we fill in here to get the proper values for x prime and x dot prime? Well, let's think. What should our position be, our predicted position, after some time has elapsed? Well, we want to include our old position, right? So let's first draw these, or write out these formulas. We expect that x prime will be composed of our old position plus whatever motion was occurring due to the velocity. And that is going to be dt, so the time elapsed, times our velocity. This is just velocity times time, which tells us how much our position has changed. Now, in matrix terms, how do we express that? Well, we're talking about x prime, so that means we're going to think about this top row here. And we want to keep x, which means a 1 goes here. We want to multiply x dot by dt, so that means a dt goes here. And just like that, we figured out the first row of our F matrix. I'll label it here, F. Now what about the second row? Let's do a similar thing for x dot prime to figure out what should go in the second row. So after our prediction, we said that we're just going to assume that the velocity hasn't changed. Velocity after equals velocity before. So that means we don't want to have anything to do with this x, means a 0 goes here, and we want everything to do with this x dot. We want to keep this, so we put a 1 here. Okay, so this kind of gives us some intuition for how this works in 2 dimensions. Let's see if we can generalize to 4. So now, again, we're going to some new state. And we're doing that by multiplying a state transition matrix by some old belief. But now instead of x and x dot, we also have y coordinates. So we have x, y, x dot, and y dot. And here we're going to, of course, get x, y, x dot, y dot, and all of those are prime because they indicate after our prediction. Now I'm not going to fill in this 4x4 matrix for you, but I think using similar reasoning to what we did in the two-dimensional case, you can come up with what these formulas should be, and from that, fill in this matrix appropriately, remembering that this entry corresponds to the first row, this entry the second, and so on. Good luck!